Look up at the night sky for a moment. It feels like the universe is full of stars, galaxies, and glowing clouds of cosmic light, a vast, crowded ocean of matter stretching in every direction. But here's the astonishing truth. Almost everything you see in the universe is the exception, not the rule. Between stars lie enormous distances of emptiness. Between galaxies stretch regions so vast and silent they contain almost nothing at all. In fact, most of the universe isn't made of stars, planets, or galaxies. It's made of space. So why did the universe end up this way? Why didn't matter spread evenly everywhere after the Big Bang? Why did gravity gather matter into tiny islands surrounded by immense cosmic voids? In this video, we're going to travel across an extraordinary range of scales. From the empty space inside atoms, to the quiet gaps between planets, to the gigantic cosmic voids that span hundreds of millions of light years. And by the end, you may realize something surprising. The universe isn't just a place filled with objects. It's a universe defined by emptiness. When people picture the universe, their minds usually fill with brilliant stars, glowing nebulae, and majestic galaxies drifting through space. It feels like the cosmos should be overflowing with light and matter everywhere we look. But when astronomers measure the universe carefully, they uncover something deeply surprising. Most of the universe is not filled with objects at all. It is overwhelmingly empty. Imagine standing in a vast desert at night, looking in every direction. Now stretch that desert across billions of light years, replacing sand with darkness. That image is actually closer to the real structure of the cosmos than a sky crowded with stars. The universe is mostly an enormous expanse of quiet, open space. Even within galaxies, the distances between stars are staggering. If our sun were the size of a small coin placed in a city square, the nearest star would be hundreds of kilometers away. Between them lies almost nothing. No thick clouds of matter, no dense cosmic fog, just a deep, silent emptiness stretching across unimaginable distances. This raises a strange and fascinating question. Why didn't matter spread out evenly everywhere after the universe formed? Why are there isolated islands of stars and galaxies surrounded by vast cosmic oceans of emptiness? What process sculpted the universe into this peculiar pattern? At first glance, the cosmos appears rich and full of structure. Yet beneath that beauty lies a startling truth. Most of existence is simply space itself. To understand why this happened, we need to look more carefully at what astronomers actually observe. And those observations reveal that emptiness is not just common. It is everywhere. When astronomers map the universe, they don't just see scattered galaxies floating randomly through space. Instead, a remarkable pattern begins to appear across the cosmic landscape. Galaxies gather together in clusters and long filaments, like glowing threads stretching across darkness. And between those threads lie enormous regions where almost nothing exists. These regions are known as cosmic voids. They are some of the largest structures in the universe, vast bubbles of near emptiness. Some cosmic voids stretch hundreds of millions of light years across. Inside them, galaxies are incredibly rare, sometimes almost completely absent. To visualize this, imagine a giant sponge floating in water. The solid parts of the sponge represent clusters of galaxies and cosmic filaments, but most of the sponge is made of holes and empty pockets. In many ways, the universe is structured in a surprisingly similar way. Astronomers discovered this pattern by carefully mapping the positions of millions of galaxies. Large sky surveys revealed that galaxies are not spread evenly like grains of sand. Instead, they trace out a gigantic three-dimensional web across space. This structure is now known as the cosmic web. And here's the astonishing part. The glowing galaxies we see in the night sky are actually the minority. Most of the universe exists inside those enormous dark voids between structures, which leads to an even deeper realization. Emptiness is not just a feature of the cosmos. It may be built into matter itself. At first, emptiness seems like a feature of the vast universe, something that exists only between galaxies and stars. But when scientists look closer, something astonishing appears. Even the smallest pieces of matter are not solid and packed together as they seem. In fact, emptiness begins at the deepest level of reality itself. Everything around us, rocks, oceans, air, even our own bodies, is made of atoms. For a long time, people imagined atoms as tiny solid spheres, like microscopic marbles. But modern physics revealed a completely different picture. Atoms are mostly empty space. At the center of every atom lies an incredibly tiny nucleus. It contains protons and neutrons packed together in a dense core. Around this nucleus, electrons move in vast regions of probability, and between them lies a surprisingly enormous amount of empty space. To understand this scale, imagine enlarging an atom to the size of a football stadium. In that stadium, the nucleus would be about the size of a small marble sitting at the center. The electrons would exist somewhere near the outer edges of the stadium. Everything in between would be almost completely empty. This means that the solid objects we touch every day are not truly solid. They feel solid because of electromagnetic forces pushing atoms apart when they come close. But structurally, matter is more like a delicate framework floating in emptiness. And if emptiness already exists inside atoms, it begins to hint that the universe might be built on the same principle at every scale. Now zoom outward from the microscopic world of atoms to something far more familiar, our own cosmic neighborhood. The solar system may seem crowded with planets, moons, asteroids, and comets, but when scientists examine the distances between these objects, a striking pattern emerges. Even here, space is overwhelmingly empty. Imagine shrinking the sun down to the size of a large beach ball placed at the center of a stadium. In that model, Earth would be a tiny marble orbiting roughly 30 meters away. The nearest planet, Mercury, would still be several meters from the sun, and between them lies almost nothing at all. Now consider the distance between Earth and the Moon. It might look close in the night sky, almost like a neighboring companion. But in reality, nearly 30 Earths could fit side by side in that gap. The space between them is mostly silent vacuum. The same pattern repeats throughout the solar system. Jupiter, Saturn, Uranus, and Neptune drift through enormous regions of open space. If you were traveling between planets, you could fly for months or years without passing anything nearby. The solar system is less like a crowded city and more like isolated islands in a vast ocean. And the farther we travel from the sun, the emptier it becomes. Beyond the planets lie distant belts of icy debris and the mysterious Oort cloud. But even these regions are incredibly sparse compared to their enormous size. Which raises an intriguing thought. If emptiness dominates even our own solar system, what happens when humans actually explore it? When humanity began sending spacecraft beyond Earth, scientists quickly discovered something remarkable. Space was not just empty in theory, it was empty in practice as well. Spacecraft traveling between planets spend most of their journeys moving through vast regions of near-perfect vacuum. For millions of kilometers, there is almost nothing around them at all. Take the journey of probes like Voyager or New Horizons. After leaving Earth, they traveled for years through the solar system without encountering anything resembling dense matter. No clouds, no thick atmospheres, no obstacles drifting through space. Just an immense, silent void stretching in every direction. Yet this emptiness is not completely inactive. Invisible streams of charged particles flow outward from the sun, forming what scientists call the solar wind. Tiny grains of interplanetary dust drift quietly between the planets, and faint cosmic radiation constantly passes through the vacuum of space. Understanding this environment is essential for space exploration. Satellites must be designed to survive radiation and extreme temperature changes. Astronauts depend on spacecraft that can protect them from high-energy particles traveling through the void. Even communication signals must cross millions of kilometers of empty space to reach Earth. So while space may appear empty, it still shapes the way humanity explores the cosmos. Every mission beyond Earth must navigate this vast vacuum carefully. And as scientists study these empty regions more closely, they begin to notice something even more fascinating. The same forces that create empty space also sculpt the entire architecture of the universe. To understand why the universe contains so much emptiness, scientists turn to one of the most powerful forces in nature: gravity. Gravity is the invisible attraction between objects that have mass. It pulls planets toward stars, moons toward planets, and galaxies toward one another. But strangely enough, this force that gathers matter together is also responsible for creating vast empty spaces. Imagine dropping a handful of sand onto a table and gently shaking it. Instead of staying evenly spread out, the grains begin forming small clusters. Some areas accumulate piles, while other regions become bare. Gravity behaves in a surprisingly similar way on a cosmic scale. When matter in the early universe began moving under gravity's influence, it didn't collapse uniformly everywhere. Tiny variations in density caused some regions to pull in more material than others. Over time, these slightly denser regions grew larger and stronger. They became the seeds of galaxies, stars, and massive cosmic structures. As matter gathered into these dense regions, the surrounding areas lost material. Like water flowing downhill into valleys, matter slowly drained away from some parts of space. Those regions gradually became emptier and emptier. This process created enormous cosmic voids between clusters of galaxies. So gravity doesn't just build stars and galaxies. It also carves out the great empty regions of the universe. The same force that pulls matter together also leaves behind vast stretches of space where almost nothing remains. And this process began very early in cosmic history. To see how it shaped our own solar system, we have to travel back billions of years to its birth. About 4.6 billion years ago, our solar system began as a vast cloud of gas and dust drifting through space. This cloud, known as a solar nebula, stretched across a region far larger than the present orbits of the planets. At first, the material inside it was spread thinly across a huge volume of space, but gravity slowly began pulling that scattered matter inward. As the cloud collapsed, something fascinating happened. Most of the material gathered toward the center, where pressure and temperature began rising rapidly. This growing core eventually ignited nuclear fusion and became our sun. In the process, an enormous amount of surrounding space was left nearly empty. Around the newborn sun, the remaining gas and dust formed a rotating disk. Within this disk, tiny particles began colliding and sticking together. Grains became pebbles, pebbles became rocks, and rocks slowly formed larger bodies called planetesimals. Over millions of years, these objects merged to form the planets we know today. But as planets grew larger, their gravity began reshaping the solar system. They swept up nearby debris, pulling in smaller objects or flinging them away. It's a bit like a snowplow clearing a road, pushing material aside as it moves forward. Gradually, the space around planetary orbits became cleaner and emptier. What remained was a solar system with a few large bodies separated by enormous distances. Most of the original material had been gathered into the sun and planets. The rest was scattered into distant belts or ejected entirely into interstellar space. And this process of gathering matter while leaving emptiness behind echoes across the entire universe. At first, the emptiness of space might seem unsettling. A vast, silent vacuum stretching endlessly in every direction. But for Earth, and for life itself, this cosmic emptiness has played a surprisingly protective role. In many ways, the stability of our world depends on how empty the universe is. Imagine if stars were packed together like lights in a crowded city. Gravitational forces from nearby stars would constantly disturb planetary systems. Orbits could shift, planets might be pulled away from their stars, and cosmic collisions would become far more common. Life would struggle to survive in such a chaotic environment. Instead, the stars are separated by enormous distances. The nearest star to our sun, Proxima Centauri, lies over 4 light-years away. That's roughly 40 trillion kilometers of mostly empty space between two neighboring stars. This isolation allows planetary systems like ours to remain stable for billions of years. Because of this stability, Earth has experienced long periods of relatively calm cosmic conditions. Seasons follow predictable patterns as our planet orbits the sun. Day and night cycle steadily as Earth rotates on its axis. These regular rhythms created an environment where complex life could slowly evolve. So the emptiness of space is not just a passive backdrop. It quietly shapes the possibility of life. Without these enormous cosmic distances, Earth's environment might never have remained stable long enough for biology to flourish. And when astronomers zoom out to the largest scales imaginable, they discover that this pattern of matter surrounded by emptiness becomes even more dramatic. Entire galaxies themselves are arranged in an immense cosmic structure. When astronomers zoom out far beyond our solar system and even beyond our galaxy, the universe begins to reveal an astonishing pattern. Galaxies are not scattered randomly through space like grains of sand in the wind. Instead, they form a vast interconnected structure stretching across billions of light years. This structure is known as the cosmic web. In this enormous web, galaxies gather along long filaments of matter. These filaments connect massive clusters of galaxies, forming bright intersections across the universe. Between them lie immense empty regions called cosmic voids. It's a bit like a gigantic three-dimensional spiderweb woven across space. To visualize it, imagine soap bubbles packed together inside a foam. The thin walls between bubbles represent the regions where galaxies collect, but the interior of each bubble is mostly empty space. On cosmic scales, the universe looks surprisingly similar. Some of these cosmic voids are so large that they dwarf entire galaxy clusters. They can stretch hundreds of millions of light-years across. If our Milky Way galaxy were placed inside one of them, the nearest neighboring galaxies might be unimaginably far away. It would feel like drifting alone in an immense cosmic ocean. What's remarkable is that this web-like pattern did not appear instantly. It slowly emerged over billions of years as matter moved under the influence of gravity. Tiny differences in density in the early universe gradually grew larger and larger. To truly understand why the universe ended up this way, we must travel all the way back to its earliest moments. To understand why the universe contains vast empty regions, scientists rewind the cosmic clock all the way back to the beginning. Nearly 13.8 billion years ago, the universe emerged from the event we call the Big Bang. In those earliest moments, the cosmos was incredibly hot, dense, and filled with energy. Matter and radiation were packed together in a uniform cosmic fireball. At first glance, this early universe might seem perfectly smooth, but when scientists study the faint glow left over from that time, the cosmic microwave background, they discover something subtle. Tiny variations in temperature and density were already present. Some regions contained slightly more matter than others. These differences were extremely small, almost unimaginably so. But gravity has an extraordinary ability to amplify even the tiniest imbalance. Regions with just a little extra matter began pulling in more material from their surroundings. Like a snowball rolling downhill, these dense regions gradually grew larger. Over hundreds of millions of years, these growing clumps of matter eventually formed the first stars and galaxies. Meanwhile, the surrounding regions slowly lost material as it flowed toward these gravitational wells. The result was a universe where matter concentrated in certain places, and the rest of space became increasingly empty. So the vast cosmic voids we see today were not created suddenly. They emerged from tiny fluctuations present at the very birth of the universe. The structures we observe, galaxies, clusters, and enormous voids, are the result of billions of years of cosmic evolution. And this realization leads to an even deeper question about our place within such an immense and mostly empty cosmos. When people imagine the universe, they often picture brilliant galaxies and glowing stars filling every corner of space. But the deeper scientists explore the cosmos, the clearer a different reality becomes. The universe is defined not only by what exists within it, it is equally defined by what is missing. Vast regions of cosmic emptiness stretch between the luminous islands of matter. Galaxies drift through darkness separated by distances almost impossible to imagine. Even within atoms, within solar systems, and within galaxies themselves, emptiness dominates. The universe, it seems, is mostly silence punctuated by rare sparks of light. And yet, within these tiny islands of matter, something extraordinary has happened. On at least one small planet orbiting an ordinary star, matter organized itself into life. Life eventually developed consciousness capable of asking questions about the cosmos. In the middle of this immense void, the universe began to observe itself. This realization can feel both humbling and awe-inspiring. Our planet is a microscopic speck in a galaxy of hundreds of billions of stars. That galaxy is only one among trillions scattered across the cosmic web, and most of the universe surrounding them is quiet, open space. But perhaps that emptiness is not meaningless after all. It provides the stage on which galaxies form, stars ignite, and planets like Earth emerge. Within this vast cosmic silence, rare pockets of complexity appear. And somewhere within that darkness, curious minds continue looking up and wondering why the universe is the way it is.